We've now covered every component of the ACI logical model, and by the end of this nugget, we'll have reviewed everything from start to finish and see the entire model laid out before us. As we build the ACI logical model from the ground up, we start with endpoint groups at the bottom. Endpoint groups, or EPGs, these are where all of our endpoints are allocated within ACI fabric. So as ACI tracks all of the endpoints that we spin up, they need to belong to an endpoint group. And one of the most critical pieces of information is that endpoint groups cannot talk to other endpoint groups, at least until we deploy a contract between two endpoint groups. Contracts are like access lists, except they don't have IP addresses, and they enable communication between endpoint groups. Also keep in mind that there are providers and consumers, so if we apply a contract unidirectionally, the provider is the one that is providing the contract to the consumer. And that's how the consumer knows how it's allowed to access the provider. Next, EPGs belong to bridge domains. A bridge domain is a layer 2 domain that is a unique MAC address space, and it also controls the broadcast. We talked about how we can enable ARP and unknown unicast flooding within a bridge domain. We also assign subnets here, and the subnets that are assigned to a bridge domain can be shared among the EPGs. And the EPGs can likewise access the gateway addresses that we provide within the bridge domain without having to configure contracts to do so. Next up is the application network profile. And the application profile doesn't really fit into the building block nature of the ACI logical model. Instead, it stretches itself across multiple bridge domains to encompass endpoint groups and contracts. Application network profiles tell ACI which endpoints and endpoint groups are part of a specific application. And as we discussed, that allows us to see health scores, as well as provide policy against an application, giving us a more application-centric view of our environment. Next up, bridge domains and application network profiles belong to a single context. A context is a VRF, which is a virtual routing and forwarding instance within the network configuration. This is a unique IP space, and so whereas a bridge domain is a unique MAC address space, a context is unique IP addresses. Meaning if we have a second context over here, we can have duplicated IP addresses between the two. Contexts are primarily going to be used from a multi-tenancy perspective, especially, for example, if two companies merge together and there are duplicated IP addresses within that environment. Finally, the highest layer of the ACI logical model is the tenant. And the tenant doesn't have an equivalent to traditional networking because it's not a network or a technical construct. This is from a management perspective. We assign all of these building blocks to a tenant so that when a user logs into the ACI fabric, they aren't messing with other tenants' policies. So if we have a service provider that has 20 tenants, the traffic isolation itself is happening at the context or VRF layer. Meanwhile, the tenant management layer allows us to manage those tenants without causing misconfiguration and other problems between tenants. So that's it for the ACI logical model. Congratulations on finishing this series. I hope this has been informative for you, and I'd like to thank you for viewing.